Good evening once again. Welcome to our channel in Eugene. So it has been so long, but I'm here for you for today. Now this one we are gonna continue to our courses. Now for today we are gonna look about overcurrent protection. For last time we have seen about this video current protection. As a reminder, we have seen that for the residual current protection, we have said that for a residual current protection, we use a device called residual current device, where this residual current device measure the imbalance between live and neutral, so that when there is imbalance between live and neutral, it carries the circuit under a principle of using a toroidal coil, where the live wire comes and it goes to the load. Similarly, a neutral wire comes, it passes, and it goes to the load. But for this, it's not possible. Now, as in the normal, this is right, this is neutral, as we have said. As the normal, the current that's passed to the live wire must be equal to the time of the neutral. So, for this coil, they produce magnetic flux, the rotating magnetic flux which produced there always be the same, and the circuit becomes working fluently without having any problem. So, but for this, sometimes when the circuit has a problem and the current there is imbalance, we had a tripping mechanism as a breaker. But this tripping mechanism, it is of a coil which operates by a difference of the flux that comes from the third coil. This third coil called a search coil, but the production of it is somehow slow. It is somehow low. We pass through to a magnifier, so that is magnifier, and now able to operate this coil. This is the contact of live. This is the contact of neutral, and for this we have a testing resistor where we can take here to see whether it works. We have the test switch for this, and we have a resistor for here. This is the testing resistor. You just pass through here, and just this goes here. Why for this? For testing. You see now when I cut the current without going through here and just I reflect this, always also there is no longer imbalance, so the production of a supplement magnetic flux is there, and now we'll be able to trip this coil, and now it breaks the circuit. And for this, remember the psychological thing will no longer accept. So for this, it will no longer protect the overcurrent, where overcurrent in the circuit we have the two sources of it, either by overloading, and short circuits. Now, when the overcurrent may they come from overloading. This is when you plug a lot of appliance greater than what the circuit can handle. It is sound, the circuit can sound. So for this, we need to protect it to a certain magnetism to avoid the insulation of the cable to burn or to get damaged. But for the circuit, for circuit, it is a limited impedance. So we have a special device called a miniature circuit breaker. For this, it works up to a circuit with 100 amps. For the current goes for this, we no longer use a miniature circuit breaker. We use a multi case circuit breaker, where it works for over 100 amps. Now, for this, the working principle, the technology that made them are similar. They use the metallic material so that when the current goes high, it can trip the circuit due to the metallic material inside. But for their difference, it is the setting and the technology they have. It is what they have as a difference, and also the amount of the current it can handle. So this is what. But for this, they have different classes where we can just have type. We have classes. We can have class B, known as type B, C, and D. For this, where they differ, for type B, it used for heating element or a small other appliance, where they can trip 2, 3 to 5 times of their full load, of their tripping current. And let's look for type C. It goes from 5 to 10 times, and while for this it goes 10 to 20 times. Now, these two applications, you can select a class of a miniature circuit breaker or MCCB. Like when I have the resistive, I can select here. For the inductive load, they didn't trip directly. They no longer start directly. They require inertia. So once they have the inertia to move from rest to put in motion, it drags much current but a very short time, so that it can reach to 7 times of the 7 times the electric current. So by the current, if they have type C, will no longer trip. But remember, for the charging station in the X-ray, they can just drag much current in the battery charging station. So they drag much current to the starting. That's why the type is D, it is the preferred D type. Now, who can ask by yourself now? Which current we are talking? How can you calculate the current? If we are saying, how can you calculate the current? Now, this, it is delivered in the formula of power, where we know that the power for a single phase, let's first of all take for a single phase supply, it is equal to the voltage times current times the cosine theta, which is the power factor. So the current is delivered from this, it is equal to the power divided by voltage, the cosine theta. So this is the current a circuit it can just be dragged by any appliance flowing to the circuit, or what the current an appliance can consume to produce a certain heat, if it is heat, if it is light, or it can be the rotating power, if it is the motor. So this is the current we are talking. This SD say I, which is equal to the IB, and we call it the design current. If this current, it is the design one, but sometimes when it is going to start when the current, when the load is going to start, it drop much current greater than this. So that's why for such the current breaking capacity of the protection device, as we have seen, we are no longer, we have a tolerance. We have a tolerance where we say that we have a 25% additional to the full load current. So for this now, simply it means it is the current of the breaking of the circuit breaker, let's call it IN, will be equal to 100% plus 25% of the design current, which will be 1.05 IB. So for this, we get the protection of that current that will break it. But now, what current will block will no longer pass in air. It has something to carry. Which one? We have to look about, it is the cable. So as if we protect the circuit, this current is passing through the cable. So what we need to protect now, we need to protect the cable for working efficiently, for removing such things which can harm the insulation of the cable. So for our side, let's look how will I get the current, the current carrying capacity of the cable, so that when this breaker breaks the circuit, the cable will no longer block. So for this, we had a formula which we can find in how the IB and the IN, which is equal to 1.25 of IB. Now, there is, if we say this is the IN, and the IN will protect the current IN, it is the current breaking capacity of a circuit breaker. If it is the current breaking capacity of the circuit breaker, and now the circuit breaker will break the current that will pass through the cable, the rating of the cable, it should be greater than current breaking capacity of a circuit breaker. Now, for us, most of the time when we are working with, if you are in Rwanda, and you are working for an electrical installation permit that will be provided by Lula, it is better to use this formula where I, IZ should be greater, IN, and IN should be greater than IB. Where this is the current, that's the current carrying capacity of the cable, should be greater what will protect it, which is the current rating of the circuit breaker. The circuit breaker will greater to the IB. Now, if why this formula varies and how we can explain it. Now, let's begin here. This is the design current, the current it drags. But remember, when an appliance starts, it can drag much current. So for allowing it to no longer trip, this one must have a greater rating. By adding its the tripping time based to its technology and its type, it works. But if this one goes to this can break. So that's why the rating of this cable must be greater the rating of IN. So this is what I was supposed to tell you today, but what will be the next session? Now, for the next session, we could do a further development about how can we calculate the current carrying capacity of a cable and selecting the required size of cable based on the current passed through it, based on the current passed through it, and the environment condition. What will happen when the current, when the cable is conducted with other, if it is lying in open environment, when it is an underground, when it is lying on a cable stretch. So all things it will be on our next session. Make sure and comment, subscribe to our channel so that our comment for our session, it becomes our power to develop different skills or different practicals you want. So make sure or comment and what will you prefer to discuss on the next session. Thank you for today. I hope everyone enjoyed the video. Thank you so much.